This is a notes handout that I printed for you, so you guys should have that. So we look for our P's and Q's. Where do you look to find your P values? Constant. What is everything that divides 2 evenly? Good. And Q, where do we look for that? Alright, and what goes into 6 evenly? 1, 2. Okay, and from that we made a list of possible zeros. And how did we find those? Divided by Q. So everything gets a plus or minus. So 1 over 1 is 1. 1/2. 1/3. 1/6. 2 over 1 is 2. 2 over 2 is 1. I already have it. 2 over 3 is 2/3. 2 over 6 is 1/3, and I already have it. So that's everything I need. What did we do after this? Plug them in until find one that makes it equal 0. Alright, so you guys start plugging them in. Which ones would we probably want to check first? 1 and -1, 6, 2. Try to avoid the fractions if you can. You can't always. But see if any of the whole or the integer. So if 1 works, we will do our synthetic with 1. 6 comes down. 6 times 1 is 6. 7 plus 6 is 13. 13 times 1 is 13. -12 plus 13 is 1. 1 times 1 is 1. Plus -3 is -2. -2 times 1 is -2. And that gives me 0. What if that didn't equal 0? You did something wrong. Either it wasn't really a 0 or you messed up your synthetic division. So you would need to double check. Don't just like make it a 0 and keep going, because you're not going to get the right answer. So we are left with 6x cubed plus 13x squared plus x minus 2. This didn't happen yesterday. Yesterday all the problems we were left with were quadratic, so we could factor them. The reason we still have an x cubed is I started with a higher power. My original was an x to the 4th, so how many zeros would I expect? 4. So I'm not done. I need something else. Is this something I can factor nicely yet? No. But it still can be divided. The possible zeros are the same, so we just need to find another one that works. Now, 1 worked once. It's possible it could work again. But if you plugged in a number the first time and it didn't work, it still won't work. And you can plug them into this new polynomial. It'll save you just a little bit of time. You have a smaller polynomial to deal with. So now we're plugging numbers into this, trying to find something else that makes it equal 0. And we might need to, everybody find one. Let me know when you get something that works. There's a lot of positives here, so I'd probably check a negative number. Okay, so my coefficients, 6, 13, 1, and -2. 6 comes down. 6 times -2 is -12. Plus 13 is 1. 1 times -2 is -2. Plus 1 is -1. Multiply and we get 2, and that adds to 0. So we have 6x squared plus x minus 1. So if we slip and slide, multiply -6 and add to +1. Divide those by 6. We get 2x plus 1. 3x minus 1. Is that my final answer? No, I wanted the zeros and the factored form. For my factored form, that's all the parentheses. So f of x equals, we have these, what else do we need? We had 1 was a 0, so it would give me an x minus 1. Negative 2 is a 0, so it would give me x plus 2. Zeros are just the numbers that make each of those parentheses equal 0. If you have trouble seeing that, you can certainly work it out. If you want to know what makes 2x plus 1 equals 0. You can solve it, and we get and why did I get 4 zeros this time? X to the 4th. So that highest power, or degree, is telling us how many zeros we are getting. Any questions on that? Let's try another one. How many zeros do you think we're going to get this time? 5. All right. Let's go. The p-values, what would those be? Would be easier to write them in pairs. How about 1 and 48, 2 and 24. You can certainly put them in order, but this one has a little more, so this might be easier. 3, 16, 4, and 12, 6, and 8. Okay, Q. What is my leading coefficient? What's everything that divides 1? Okay. So, possible zeros, P over Q. What are we getting? All those p-values. Can I just draw an arrow? Okay. So my p-values are my possible zeros. Okay, we need to find one that works. This may take a minute. Let's see what we get. Try 1, -1, do 2, 2, -2, do 3, -3, 4, -4. Let's see if any of those work. So you're plugging them into the original equation, replacing the x's, and seeing if it equals 0 when you do that. And do you guys know, like, if you type one in, if you hit second enter, you can bring it back and just go back and type over your number. You don't have to retype the whole thing. You're good. Okay, so we do our synthetic. We can do it with -3. And someone has told me that 2 also works, so we'll do it. So at this point, we have an x to the 4th minus 4x cubed plus 8x squared minus 16x plus 16. So definitely not something we can factor nicely yet. We just have to keep going with this synthetic with another 0, and we're dividing this quotient that we got out. So that's what I'm going to be dividing the next time. And anything that worked on the first one will still work. So someone said 2 worked. So let's do synthetic with the 2. Okay. Now what? Find another one. Is it possible that -3 or 2 would work a second time? Yes. Any number that we've already checked, though, that didn't work still won't work. So we checked quite a few of them and no one else got one that worked. Let's check 2 and -3 again to see if any work in this new polynomial. So how about this half the classroom, you guys check 2, you guys check -3. Two works again, all right. Remainder, constant x and x squared. So we have x squared plus 4. All right, so I asked you to find real zeros. If I say real zeros, do I want imaginary numbers? No. Does x squared plus 4 factor nicely? No. If you set it equal to 0, you're getting positive and negative 2i. So those are imaginary zeros. Now, I could very well ask you for all real and imaginary zeros, and if I did, you would include those. If not, then we don't have to go that far. So our factored form, x squared plus 4 doesn't break down anymore. So I'm just going to leave it as x squared plus 4. 2 worked, so that's x minus 2. How many times did it work? Twice. So what would I do? Square it. And what else worked? Alright. My zeros. Okay, if I asked you for all the zeros, you would give me the imaginary. Since I only said the real ones, what makes x minus 2 equal 0? 2. Since the 2 worked twice, we are actually going to say 2m2. The m stands for multiplicity, which is how many times the solution works. That is going to be important when we start graphing these polynomials. When something has multiplicity, it will impact the graph. So I just want to get in the habit now of writing down when something has a multiplicity, when it's a 0 more than once. So we got 3 zeros here, 2, 2, and negative 3. We said we would have 5. How come I don't have 5? 2 are imaginary. Now, if I said list all the zeros, we would include the plus and minus 2i. All right. How are we doing with these? Good. Why don't we go ahead and do last one like this for the day. All solutions. So it could be real, it could be imaginary. I want anything that works. What are my p-values? And my q, what goes into my leading coefficient? So my possible values are the p's. So I'm just going to draw an arrow. Okay, find one that works for me. Maybe find a couple. It's next to the fourth pi. Another one?
-1.
Okay. So let's go ahead and we'll just pick one to start with.
Wouldn't it be -1 on the second?
Oh, yeah. Where did I get -3? Apparently I'm tired today. Alright, so 1 comes down, 1 times 2 is 2, plus a1 is 1. We have x cubed plus x squared plus 4x plus 4. So now you said -1 also worked? So I'll take that answer I just got out and divide it with the -1. squared plus 4. So I've asked for the factored form and the zeros. Okay, x squared plus 4, does that factor nicely? No. So you can leave that as x squared plus 4. Negative 1 works, so we have an x plus 1. 2 works, so we have an x minus 2. Does it matter if you write these parentheses in a different order? No. Alright, the zeros. This time I didn't say only the real ones, so I want all of them. So if I want to figure out what makes x squared plus 4 equal 0, so plus and minus 2i, negative 1 and positive 2. It would also be okay for x squared plus 4. Could you write x plus 2i and x minus 2i? Yeah. I'll take it either way. I don't care. So only difference on this question versus the previous one. Previous one I only asked for the real zeros, so you didn't have to include the imaginary. This time I said all, so you had to list the imaginary ones. Do we need any more like this? So last couple things that I want to talk about today. What we've been using is really what's called the fundamental theorem of algebra, which tells us if you have a polynomial, you're going to have a zero. Okay? It could be real, it could be imaginary, but there are zeros out there. Furthermore, that degree, that highest power, is the number of zeros. Now, do they all have to be real? Absolutely not. But if you have a degree of 7, there are 7 zeros out there. Just some of them might be real, some might be imaginary. So if I'm just going to jump. Okay, so skipping a couple slides that just recap what I said. So if you just look at this, how many zeros could this have? 5. At most 5 real zeros. We're guaranteed to have 5 zeros. Some of them could be imaginary. So final slide of the day. I want to create a polynomial of degree 3. So that means my highest power is an x cubed. That meets the following requirements. If negative 3 is a 0, what has to be in my polynomial? Okay, if negative 2 is a 0. If 5 is a 0. Okay, would that have degree 3? Yes. So we've met those requirements. What is this telling me? Okay, when I put in negative 1, it has to equal 6. Now technically, I can't put any more x's in this, right? Because then it wouldn't be a degree of 3. But could there be some number out in front? We saw that with our quadratics. Remember that we had a couple problems where we had to write an equation for them? So let's figure out what that number is. So if my x is negative 1. So if I replace all my x's with negative 1. This thing has to equal 6. So 1 plus 3 is 2. And 1 plus 2 is 1. 2 times 1 times negative 6 is negative 12a equals 6. Divide by negative 12, so my a is negative 1/2. So my polynomial is negative 1/2 times x plus 3, x plus 2, x minus 5. Couldn't put any more x's in because my degree is only 3. There can only be 3 x's. So to meet that last requirement, we had to put a coefficient in front. Any questions on that one? So let's do B. If 4 is a 0 with a multiplicity of 3. If 4 is a 0, what do we have to have? The multiplicity of 3 means we have this 3 times, or we could just say f of 2 equals negative 24. So we know there could be a number in front when I put in 2 for my x. It equals negative 24. Negative 2 to the third is negative 8a. Equals negative 24. Divide negative 24 divided by negative 8. 3. So my polynomial is 3 times x minus 4 cubed. Are there any questions? So, we are done with this second part. You've got the assignment there. We are adding it with last night's homework. Tomorrow we will finish it and have our final piece of this assignment. So you have a lot more time than you're used to.